Good afternoon, everybody. Mathematics, IGCSE, and we are working through exercise 5.13 and 5.14. 5.14 is calculator work, so we won't be doing that much there, but there's a couple of issues in 5.13 which I want to work through with you. Note this, that how these things work. If we have a fraction of 1 in 10, 1 in 100, and 1 in 1,000. The bigger the number at the bottom, the smaller the value gets. Okay? We can write this as 1 over 10 to the power of 1, 1 over 10 to the power of 2, and 1 over 10 to the power of 3. If you know your indices or your exponents, you will know that when this moves up to the top, it becomes 10 to the power minus 1. This becomes 10 to the power minus 2. This becomes 10 to the power minus 3. So that is why these small numbers, exponents, are negative. So the bigger this gets, the bigger the negative exponent is. Okay. Right. We move on to the exercises in 5.13. Exercise 1C. Just doing a few examples, just to show you how it works. Exercise 1C, they have a number written in normal form, and there's 4 zeros and then 3, 2, and they want us to write that in standard notation. So this we can then write as we see how many positions we must move this point to get to 3.2. 1, 2, 3, 4, 5. So therefore this is 3.2 times 10 to the minus 5. Because if we write 3.2 and we go minus 5 we move the point to the left. 1, 2, 3, 4, 5. And there's our point. And then we're back where we started, okay? So I prefer to move the point and not the digits, as they say in the book, because my head doesn't want to get around the digits. So just remember, this with all the zeros after the point is a very small number. Whereas if you have a lot of zeros after the number and then the point, it's a very big number. Okay, right. Question 2C. 2C. Here we have 2.03 times 10 to the minus 7. And they want us to write it as a normal number. So we write 203. And we've got to go minus 7, so we've got to move our point to the left 7 times, and it starts here. Here we move it here, then we start to write zeros. So we say 1, 2, 3, 4, 5, 6, 7. And there's our point. And we can put this 0 here so we don't lose that. This is an incredibly small number. This is like the thickness of a coronavirus. Okay? In millimeters. That was 2C. 3D is 11 times 10 to the minus 5 multiplied by 3 times 10 to the 2. This is, you first multiply the integers here, or the constants, 3 and 11. 3 times 11 is 33. And then you add the powers. Add minus 5 and 2. What is minus 5 plus 2? Is minus 3. So it's 10 to the minus 3. But now this is not in scientific notation yet, because, or standard notation, this point is actually here. So we've got to move the point back 1. It's 3.3 times 10 to the... If we move the point back 1, we've divided. That means we must move the point forward 1 here, we must multiply. So this becomes minus 3 plus 1. We multiplied by 10 to the 1 here, and we've divided by 10 to the 1 here. So we just have to add these powers, so it becomes 3.3 times 10 to the minus 2. Okay. Right. 3G. 4.5 times 10 to the 8 divided by 0.9 times 10 to the minus 4. Okay. 4.5 divided by 0.9 is the same as 45 divided by 9. 9 fives are 45. So 9 goes into 45 5 times. And there is your constant multiplied out. Multiplied by 10 to the, here's plus 8, there's minus 4. So we have to add these powers. But this power is divided. So it's below the line. So the sign, it's got to get a minus. But don't forget the minus that's already there. So we have 8 minus minus 4. So we have 5 times 10 to the 8 plus 4. Because a minus times a minus is a plus. So we have 5 times 10 to the 12. Okay? That was 3G. 3H. 11 times 10 to the minus 5 times 3 times 10 to the 2 divided by 2 times 10 to the minus 3. Okay. 3 times 11 times 3 is 33. Divided by 2. 33 divided by 2. Multiplied by, we just leave this as a fraction for a moment. Multiplied by 10, okay, to the minus 5 plus 2 minus 3, because that's divided. 2 goes into 33, well, 2 goes into 32, 16. And there's 1 left. 2 goes into 1, a half. So it's 16.5. Multiplied by minus 5 plus 2 plus 3. 10 to the minus 5 plus 5. 2 plus 3 is 5. But what's minus 5 plus 5? It's 16.5 times 10 to the 0. Okay? And in your indices or your exponents, you learned that anything to the power of 0 is 1. So our answer is 16.5. Or in standard notation, 1.65 times 10 to the 1. Because if you move this one that way, you'll get your answer again. 1.65 times 10 to the 1. But we don't write it like that. We write it as 1. This, in fact, this number, we don't really want to write as standard notation, but the book requires standard notation. This will be the correct way to write it, except for we won't actually put in the 1 there. But normally, you wouldn't write this in standard notation, you just write 16.5 because it's not a very big number or a very small number. Right. Let me move on to question 4a. 4a has 3.1 times 10 to the minus 4 plus 2.7 times 10 to the minus 2. Now you remember previously the book advises you to change both of these into a normal number and then add them. Then change them back into scientific notation. When you don't have these minuses here, it's quite easy, as I showed you in the other video, to manipulate this to change the biggest 10 here to correspond to the other 10, and you can just add them. But one tends to get mixed up with these minuses. So I would recommend when you have negative powers to rather change them both into normal numbers. So 3.1 times 10 to the minus 4 is 3.1. Our point is there. We're going minus 4. Minus 1, 2, 3, 4. And this one is 2.7 times 10 to the minus 2. Our point is there. We're going minus 2. 1, 2. That's that. Now we've got to add these. So we'll just put this under here. So it's 0.027. These are just zeros here. So we add this 1, 3, 7, 2, 0.0. Very easy. And we change it back into scientific notation. So this is going to be 2.73. How do we get 2.73 back to that? We go 1, 2. 1, 2. So it's times 10 to the minus 2. And there's your answer. Okay. That was it for, there's still a question 6. Yes. Question 6, just to give you an example of some application. They have the speed of light is 3 times 10 to the 8 meters per second. This is question 6. It's one of the parts of question 6. And they want to know how far does this light travel in 102 seconds. So what I do is I write 3 times 10 to the 8. But I write meters per second as meters per second. Okay? Then I multiply this by 102 seconds times 102 seconds. If you look at the units here, there's meters per second and there's seconds. This is actually over 1. You can cancel units just like you can cancel numbers. There's an S here and an S here. Seconds cancels with seconds. It disappears and your answer is in meters. And that's how you know your answer is right, because your answer must be in meters because they want to know how far. So it is 3 times 102 times 10 to the 8 meters. And 3 times 102 is 306 times 10 to the 8. And which has got to be 3.06 times 10 to the. This has got to go to 306. So it's 1, 2 times 10 to the 2. And that's your answer. Meters. Okay? Meters. We usually just use a small n for meters, but you can write it out if you want to. Okay, now we move on to exercise, exercise 5.14, which you shouldn't have any trouble with it, because it's just calculator work, 5.14. But we can just do 2 examples quickly just to show you how it works. 3H, different calculators work in different ways. So you have to get to know your calculator. If you're confused, take out the little guide pamphlet and make sure that you are on the right track. So if we've got 9754 divided by 0.0005 to the power of 4. When you see this, I suggest you use the brackets, because your calculator doesn't always know exactly where to put this for. So what I'm going to do is I'm going to key in 9. First of all, I'm going to go to this key. I'm going to use the diffraction key, which looks like this. Most calculators now have that key. When you press that key, you will get a sign like that, and then you can put your 9754 on top, and then at the bottom, use your brackets. There's brackets on the calculator. You can put first your bracket, then you put 0.0005, close your brackets, and then you'll also find a thing with an X like that with a little square above it. If you press that, then it allows you to put this 4 in there. So when you press X, it sees this as X, and you put the 4 in there. Okay, and that should give you your answer of let's see, it's 9754 divided by bracket 0.0005, close brackets, X 4 equals. And this calculator will give you your answer already in scientific notation. Although they want here the answer to the H, 5 significant figures. So you count the figures. We've got 1.56064 times 10 to the 17. I have my calculator set to give me 5 digits after that point. 5 significant figures is all of them, 1, 2, 3, 4, 5. So we're going to stop here. So your answer actually should be 1.5606 times 10 to the 17. We don't include this one because it is less than 5. We just ignore that. Okay, right. We'll move on now to the last one, which is 4B. 4.2323 times 10 to the minus 2 brackets to the power of 3. So you know from your exponents, if the power is outside the brackets, you must multiply it with the powers inside the brackets. But you don't have to worry about that now, because we're doing calculator work. So all you must know is you still use exactly the same things that I just used. You start with your brackets, then you write 4.23, you press exponent, which is the time 10 to the power of x, exponent, then you put in minus 2, you close your brackets, and then you press your X with a little block, and you put a 3 in there. And that will give me 7.5686, 7.5686, and 967 times 10 to the minus 5. Already in scientific notation, but we want 5 significant figures. 1, 2, 3, 4, 5. But don't forget this 9. This 9 is going to make the 6 one more. So our answer is then 7.5687 times 10 to the minus 5. It usually doesn't make sense when you do a calculation to get this long number. The numbers at the end of it, especially if it's a very small number, they don't really make any difference to the answer. So that is why they have the concept of significant figures. Alright, and that was it for today. Thank you very much.